Hello and welcome to the second chapter on data analytics. The second chapter deals with descriptive statistics. This is a very heavily uh, example chapter, contains a lot of information. So it's going to take us about 2 weeks to cover this. I'm going to try and go slow, give you lots of exercises to do, and hopefully all this information will become easier as we go along. So one of the first things we're going to do is look at some definitions and goals. And so some things you need to understand when we're talking about data is what exactly is data. So data can be facts and figures, anything that's collected, could be summarized data given for presentation or interpretations. Now that data then can also be under a certain variable. So a variable is a characteristic or quantity of interest that you take on different values. You might also think of this variable like a field name when we deal with tables in a spreadsheet or a field name in a database. So that's a variable. An observation then is a set of values that corresponds to that variable. So usually we're going to have a bunch of variables that go across the top of the screen, and underneath that, each row would be a set of observations. Then as we look at our data, we can also determine some variation, and that's a difference in a variable measured over a number of observations. You can have a random variable or an uncertain variable, and that's something whose value you're not known with certainty. So if we look at this example, your book contains, this is the Dow Jones Industrial Average, or companies I should say, because we haven't really computed a average yet. So here you might want to think of these, here's the variable, right? They're like field names. And then we have data that's underneath. So if we go back and look at that, then each observation then is a row that goes across. Then we can have variation, that is the difference in a variable measured over observations. Now it depends, is it going to be the same thing that's measured or is it going to be different thing that's measured? So in our example here, it's going to be different. It's a different company that has different share prices here. So that has some variation in the share prices, and we'll show how to compute that later. Also, something to keep in mind is that the data that we're collecting is usually past observations. And so what we want to do is be able to learn something about our observations by looking at the variations that's going on in it. All right, so that's that table example there. Again, look at this, make sure you could identify what the variables are, what the observations are. So each row would be an observation, and there's variation. There's variation here, there's variation here. Could be some variation in industry. We'd probably have to get some frequencies of each of the industries that are represented. Probably, yeah, everything is different here, so you're going to have 100% variation. Same thing here for the company name. I think we'll continue on here. So that just lists the rest of the table. And I found that you could actually, if you had access to these, or if you look in your book, you could grab these and do your own calculations just to make sure you're doing exactly what the book got the same results. The next thing we want to talk about are the different types of data. So we'll go over what's the difference between a population and sample data, whether the data is quantitative or categorical, what do we mean by cross-sectional and time series data, and then source of data. So the first thing to think about is, what do we mean by the population? A population is all elements of interest. And what that means is you're going to collect data on everything that's whatever you define as the population. So if we were looking at the stock market, the population would be all of the stocks that are listed in the stock market. Well, that's too many to track, and it would take too long to do all the analysis. And so what we might do is take a sample of that population. So we come up with the Dow Jones Industrial Average. And so we take 30 stocks that represent the different areas in the stock market, and then we use that to generalize to the population. Now, when you take a sample of the population, make sure that that sample is random, or you're just going to bias your results and you're not going to be able to generalize to the population. So an example that I saw was a sampling of the Mediterranean diet. How does that affect people? Well, they went to the countries where that's predominantly eaten, and they got the results that it was really good for you and all the rest. But if you took that same diet and went to a different country, would you find the same result? Or what are the popular diets in another country that don't have anything to do with the Mediterranean diet, but yet yield similar results? My point is that when you take a sample of your population, you got to make sure it's representative of the entire population so that you can generalize. That is, your findings are going to be what is found in the population, or you can say that it's found in the population. If somebody comes back and says, well, this was a biased sample, and you're not really going to be able to generalize your findings to the entire population. So you just need to be careful of that. The next thing to know is the difference between quantitative and categorical data. Quantitative data is anything that has a number or you can do a mathematical operation on. Categorical data is data in which you can't do a mathematical operation on. And that will affect what kind of statistical techniques you can perform on the data. Now, we won't get into it a whole lot in this class, but later on, if you're going to use SPSS in one of your other classes or SAS, then depending on the type of data you've collected in your column, then that's going to limit what kind of statistical technique you can do. Some more definitions to think about is, what do we mean by cross-sectional data? Cross-sectional means that the data was collected at the same time, or at least approximate same time. So that data that we have for the Dow Jones Industrial Index of companies, that would be prices and volume of all of those companies near the same point in time. So you don't want to do it, at several different places in time. I shouldn't say several. That is, collect data on a different company at a different place in time, because then your results are not going to be accurate. You won't be able to truly say, okay, is this really the average right now? Another term you might hear about is time series data. This is data that's collected over several time periods. So you might be looking at quarterly sales. So what are the sales the first quarter, second quarter, and so on? You see a lot of this in business and economic publications. Doing that kind of data collection then also helps you see trends over time and able to predict future levels for that time series. So, if something varies from quarter to quarter, you wouldn't want to take quarter one to predict quarter three. But you might want to take quarter one data over several time periods, could be years, and then use that to predict what might be quarter 1 in the future. And so hopefully near the end of the semester we'll get more into that. So here we have from your book some time series data showing what the Dow Jones index did from 2006 to 2017. You see that in around 2008 we had that significant decline, went down to around 6,000 and 7,000 by 2009, and then we started coming back up. So does this is a part of a sample data? Does this show exactly what happened to the entire stock market? And yes, it does. When we talk about data, there's also sources of data. So one area might be for an experimental study. When you have an experimental study, you've defined your variables up front. You've also defined your hypothesis. You've also come up with, okay, here's how I'm going to test to see if this hypothesis is correct or not. And so for us, the main thing is the variable that you want to look at has been identified. Then one or more other variables are used for control or manipulated so the data can be obtained and how that influences your variable of interest. So an example might be, let's say we want to do test scores in Excel. What are some different things that might influence the test scores in Excel? Well, it might be the way certain concepts are taught, how they're presented, what techniques are used by students to reinforce that. You can manipulate all that and see what the outcome would be. And the outcome is that variable of interest would be the test score. You can also have non-experimental studies. And here you're not really making any attempt to control a variable of interest, but what you are doing is gathering the data and see what the outcomes might be. So a great example would be doing a survey for a non-experimental study, or sometimes referred to as an observational study. So here we have an example of a questionnaire that a manager might ask for a restaurant. So you've got 12 different questions that you're asking the customer on how they might do on service, anywhere from excellent to poor. And so you would take all of the responses that you got from customers and then get an average for their overall experience all the way down to the value for their dollar spent. Next thing we want to look at is how do you modify data in Excel? We'll be looking at sorting and filtering data and then conditional formatting. Both of these you should have already been exposed to. If not, I'll go over them briefly here and we'll go on from there. So listed on the screen here is figure 2.3, which is the top 20 cars percent Excel spreadsheet. And what it shows is there's a percent change in sales for each model from March 2010 to March 2011, which has been calculated. And so I'm going to switch over real quick to the Excel spreadsheet so you can see it. And so what we've got here, if you look in this last column, how do we get the percent change from 2010? So we take 2011 minus 2010 divided by 2010, and that gives you the percentage change. So I typically like to think of it as the new minus the old divided by the old. Depending on what you want to do, you can then check and see if it works or not. A way to see if you got this formula correct or not is say, okay, what's 15.4% more onto this value here? So let me just go out to the side here. So we actually say plus this times this. That gives us the percentage increase plus the original value. And we see that it's 33,616, which means we've got the formula correct. Okay. Move this back over. So the next thing I'm going to do is just walk through on how you sort something. We're going to sort on the March sales. So the first thing you want to do is you want to select all of your data. So we're going to paint, we're going to click and hold and paint all of our data down through F21. Then we're going to click the data ribbon at the top. Now when I did all this clicking, I clicked off, there we go, it's highlighted again. So we're going to go to data, and then we're going to click on sort. And then you're going to make sure this is checked. It says my data has headers. And then you're going to do the first sort down, the drop down menu. And you're going to select your sales for March 2010. And you're going to go from largest to smallest. And when you're done, you click OK. Now, if you wanted to sort within that, you would click Add Level, and then that would be a secondary sort. Add Level again would be a tertiary sort, and so on. So it's sort of like the phone book. What's your major sort? What's the next sort with all those that are similar? What's the next sort after that that are all those that are similar? We're not going to do these, so hopefully I'm going to hit OK and see if that works for me. And it doesn't like that, so I'll have to delete a level. Now we'll click OK. And so then we get something like you see here, and that is sorted everything from largest to smallest for this particular column. Some interesting things of note here is if you'll see that the Honda Accord in 2011 was the highest seller, but in 2010 both the Camry and the Corolla Toyotas outsold the Honda. So you gain some insight by just doing a sort on your data and also percentage change. The question is okay, when would you need to do that? So when you're looking for some sort of ranking, then you might want to do some kind of sorting. Okay, the next thing I want to show you is how to do a filtered sort. And so the way you do that is you highlight all your data again. So I'm highlighting from A1 down to F21. You click on data, you come over here and you click this filter. When you do that, you'll notice that at the top where your field names are, or your column names, that you've got a little drop down arrow. So here what we want to do is we want to filter for just Toyota cars. So we do that, we'll click on that. Currently they're all selected, so I'm going to unselect them all, and because I just want Toyota, then I'll just select Toyota. I'll click OK. So that's a quick way of being able to do that. So now that we've got this sorted by Toyota, what exactly does this tell us? Well, it tells us for the 20 top-selling models in March 2011, Toyota made 3 of them. And then we can see the sales of those from year to year and what has changed. Now, back to using spreadsheets. If we want to get back to our original data, notice how this one has like a little funnel here. That means that's what you've been sorting on. We can click on that, and all we have to do is select all, make sure that's all checked, and that'll bring all of our data back. The next thing I want to show you is some conditional formatting. So conditional formatting makes it easier to spot different trends in your data that you might not otherwise be able to detect by just looking at the numbers. So it pulls that information out rather quickly. So what we're going to do here is we're going to highlight all of our data again, including the field names at the top. Okay, so starting here, going all the way to the bottom. You can't see it, but I've gone all the way down there. And you can grab this file. It's going to be in your student data files, and you can use it. It's called top 20 cars %. And you can just follow along and do the same thing. I would suggest that you go ahead and do that just so that you get some practice doing this if you haven't done a lot of them before. So we've got this table and the field names highlighted. So we'll click on the Home tab at the top, and then from there you're going to click on Conditional Formatting. Then you're going to select Highlight Cells Rules, this one, and click the less than from the drop-down menu. So we got it right here. And then we're going to say enter 0%. So I've typed that in. Notice that when I did 0%, it only went to this last column of trying to do some kind of formatting. Once we highlight that, we click OK. And so you can see how that pulls that out rather quickly. I have all the cars that were less than 0%. The last thing I want to show you in this is how to do conditional formatting or using data bars. So you would highlight the column that you want your data bars in. Once you do that, I wish you could see this, this quick analysis button comes up open once you highlight a bunch of different cells. I'm going to click that. Then I can click data bars, and it will show me what those data bars look like. Now notice as I scroll up, it's highlighting what those negative values were. Now in your book, they had removed these previous conditional formatting where they did the less than. I didn't remove that, but I just went ahead and did the data bars. So the data bars are like little bar charts, again, that quickly show you the differences between different items that are numeric. So they're quantitative, and so you can apply that to that type of data. So again, quickly spot, here's the biggest one graphically, here's the next biggest one, and so on. All right, so some different techniques that you can do there. So I'm going to pause there, and so when we come back for the second part, we will start by looking at creating distributions from data.